So let us start through this ohm meter. This is the portion left in our second unit. So are you getting my voice? Are you getting my voice?
Yes, sir.
Okay. So this is the ohm meter series type. So we'll study the different type of the ohm meter now. So this also depends upon the D'Arsenal movement. Means this here the movement indication is also is represented by the PMMC meter. Okay. So as far as the ohm meter is concerned, the purpose of this ohm meter is to measure the resistance. Now resistance is a passive component, and without applying any voltage or current to that component, we cannot measure that. So for measuring the resistance, generally what we do, we apply some voltage. We passes the current through that resistance, and the voltage developed or dropped across that resistance is measured, and that is calibrated in terms of the resistance value. Okay. So for the same amount of the current, if we pass to different values of resistances, so we will have a different voltage drops. So that different voltage drops basically are calibrated in terms of the resistances. So this is the way how we measure the resistance. Okay. So the same thing is here also we have drawn, we have shown this. So you can see the indication is in the ohm, and so we are starting from the 0 ohm to infinite value. So series type ohm meter, basically a D-Arsenal movement is connected in series with the resistance R1, and the battery which is connected in pair of terminal A and B. As you can see, एक बैटरी कनेक्ट किया है ए और बी टर्मिनल के बीच में, और वहां पे एक अननोन रेजिस्टेंसेस कनेक्ट किया है ए और बी टर्मिनल के बीच में, एक अननोन रेजिस्टेंसेस है, and there is a resistance R1 and R2. R2 is a variable resistance and R1 is the fixed resistance, and Rm is the resistance of the PMMC meter. Okay. So this forms the basic type of series ohm meter as shown in the figure, because इसमें ये connected in series है, resistance is R1 and R2. The unknown resistance is connected in series, that's why it is known as the series type. So R1 is the current limiting resistance, basically to limit the current, to reduce the current so that it should not burn, okay, our meter. And R2 is the zero adjust resistance, it is adjusting the zero basically. Okay. And the V is the battery, and Rm is the meter resistance, and Rx is the unknown resistance. So this is the arrangement. So to mark the zero reading on the scale, अगर मुझे scale पे zero reading चाहिए, as you can see in the scale, that is a zero scale is varying from 0 ohm to infinite ohm. So to mark the zero reading on the scale, the terminal A and B are shorted. अगर डेफिनेटली अगर मुझे जीरो चाहिए स्केल के ऊपर, तो इसका मतलब कोई भी जो ए और बी जो टर्मिनल है वो शॉर्टेड होना चाहिए, यानी कि जो अननोन रेजिस्टेंस है उसकी वैल्यू जीरो होनी चाहिए। वो जीरो तभी होगी जब वो यहाँ से ये तो टर्मिनल शॉर्ट हो जाए ए और बी, है ना, तो तभी जीरो रेजिस्टेंस होगी अननोन रेजिस्टेंस की। तो अगर जीरो इंडिकेट करना है तो ये शॉर्टेड होना चाहिए जीरो रेजिस्टेंस के लिए, अदरवाइज अगर कोई वैल्यू है, अगर कोई रेजिस्टेंस आपने कनेक्ट कर दिया इन बिटवीन द टर्मिनल ए एंड बी, तो डेफिनेटली इट विल शो सम वैल्यू। एंड इफ ए एंड बी इज ओपन सर्किट, no resistance is connected between A and B, then it must show the infinite resistance. Okay. So to mark the zero reading on the scale, the terminal A and B are shorted. That is the unknown resistance Rx is zero. maximum current flows in the circuit and the shunt resistance R2 is adjusted until the moment indicates the full scale current, यानी कि full scale deflection current. तो यहाँ पे क्या होगा, क्योंकि maximum current is flowing in the circuit now because A and B are short circuit. So basically, so indicator will indicate the full deflection here, and but the reading will be 0. Okay, and the current flowing through the meter will be to limit the current through the meter, we adjust through the resistance R2 ताकि वो मेरा मीटर की कॉइल जो है वो जल ना जाए. The position of the pointer on the scale is then referred as 0 ohms. Similarly, to mark this infinite reading on the scale, terminal A and B are open. That is, the unknown resistance Rx is infinity. So no current flow in the circuit because the A and B are open. So no current flows in the circuit and there is no deflection of the pointer. So the pointer of the position of the pointer of the scale is then marked as infinite ohm. So important point to ponder here is that that is if it is a infinite resistance, the meter needle will not move, and if it is a zero resistance, then meter needle will move to the full scale deflection, as you would have seen also in this analog multimeters. कि जब कोई रेजिस्टेंस अगर शॉर्ट होती है, कोई टर्मिनल को अगर हमें चेक करना होता है कि वेदर इट इज कंटिन्यूटी है बनी है वायर के बीच में या नहीं है, तो अगर हम लगाते हैं तो नीडल मेरी पूरी घूम जाती है, तो दैट इज कॉल्ड द जीरो रेजिस्टेंस. So let us see the calibration of series type ohm meter. Now by connecting the known values of different values, basically by connecting different known values of unknown resistances to the terminal A and B, the immediate marking can be done on the scale. अब अगर इसको कैलिब्रेट करना है तो कैसे करना है, तो आपको अलग अलग नोन वैल्यूज ऑफ रजिस्टेंसेस लगाने पड़ेंगे अननोन की जगह, और जितना उसमें डिफ्लेक्शन आपको मिल रहा है तो उसको आपको कैलिब्रेट करना पड़ेगा, उस रेजिस्टेंस की वैल्यू को मार्क करना पड़ेगा. सपोज आपने 1 किलो ओम लगाया, मीटर नीडल इंडिकेट दिखाया, कुछ वैल्यू दिखाया मीटर ने, कुछ इंडिकेशन आया मीटर पे, तो वो जहां तक इंडिकेशन पहुंचा है, पॉइंटर पहुंचा है, उस पॉइंटर पे वहां मार्क कर देंगे कि ये 1 किलो ओम को इंडिकेट कर रहा है. सिमिलरली 2 किलो ओम लगाया तो मीटर जो इंडिकेशन है वो थोड़ा सा कम हो रहेगा, लेकिन पॉइंटर मूव करेगा, लेकिन जहां पे रुक जाएगा पॉइंटर तो उसको मार्क करेंगे 2 किलो ओम. Like that, we just calibrate the whole scale of the meter by connecting the known value of resistances in place of the unknown value. So the same thing is here also. The accuracy of the instrument can be checked. ये क्या हुआ, कौन खेल रहा है भाई स्क्रीन के साथ में? The accuracy of the instrument can be checked by measuring different values of standard resistances, and that is the tolerance of the calibrated resistance, and noting the readings. So what is the major drawback in this series ohm meters? Is the so major drawback in the series ohm meter is the decrease in voltage of internal battery with time and age. That is correct. जैसे हम लोग मल्टीमीटर में जो बैटरी लगाते हैं, 9 वोल्ट बैटरी लगाते हैं, तो वो धीरे धीरे टाइम के साथ साथ वो बैटरी की वैल्यू डिक्रीज होने लगती है, तो वी हैव टू चेंज दैट बैटरी. So due to this, the full scale deflection current drops. If the battery or cell is weak, then full scale deflection current will drop and the meter does not read zero when the A and B are short circuit. The battery अगर poor है तो needle जो है full scale deflection पे नहीं पहुंचेगा. The variable shunt resistance R2 across the moment is adjusted to counteract the drop in the battery voltage, thereby bringing the pointer back to the 0 ohm on the scale. So सम ऑफ दी दिस बैटरी का जो वोल्टेज जो कम हो गया है, जो ड्रॉप हो गया है, उसको कुछ नलीफाई कुछ एक्सटेंट तक हम कर सकते हैं बाय एडजस्टिंग द रेजिस्टेंस R2 बाय लिमिटिंग द करंट. तो बट उसमें ज्यादा को नहीं कर सकते, बट सम टू दी सम एक्सटेंट वी कैन एडजस्ट दैट, राइट. So in a series ohm meter, the scale marking on the dial has 0 on the right side corresponding to the full scale current and infinity on the left hand side corresponding to the no current flows as given in the figure. That is very important point to note. The values of R1 and R2 can be determined from the value of Rx, which gives half the full scale deflection. Very important here to note here कि R and R2 की अगर वैल्यू आपको डिटरमाइन करनी है Rx वैल्यू से, अननोन वैल्यू से, so these are the value gives the half the full scale deflection. So just you see here, नाउ यहाँ पे आप देख लीजिए कि दिस आर एच इज दी बेसिकली आर एच इज द हाफ और फुल स्केल डिफ्लेक्ट हाफ ऑफ फुल स्केल डिफ्लेक्शन रेजिस्टेंस। फुल स्केल डिफ्लेक्शन जो होगा उसका जो आधा मीटर पॉइंटर होगा दैट इज कॉल्ड हाफ। तो वहां पे कितना रेजिस्टेंस होगा? सो दैट आर एच इज बेसिकली half of the full scale deflection resistance is equal to R1 plus R2 in parallel with RM। तो you can see कि R1 और R2 जो है वो सीरीज में है, but if they are in series then definitely they are in parallel with RM meter resistance, and that is equal to R1 plus R2 into RM divided by R2 plus RM। Okay, so the total resistance presented to the battery then equals to 2RH। तो अब जो बैटरी जो बैटरी को जो टोटल रेजिस्टेंस जो प्रेजेंट हुआ है, द टोटल रेजिस्टेंस प्रेजेंटेड टू द बैटरी, यहाँ पे अगर हम बैटरी के एंड से हम देखें ए और बी का जो टर्मिनल है वहां से अगर हम एंड से आप देखें तो टोटल रेजिस्टेंस प्रेजेंटेड टू द बैटरी देन इक्वल्स टू ट्वाइस ऑफ आर एच, बिकॉज ये हमने हाफ ऑफ द वैल्यू लिया था, हाफ ऑफ फुल स्केल डिफ्लेक्शन लिया था आर एच को। तो अगर मैं फुल वे डिफ्लेक्शन की बात करूं तो वो 2 RH हो जाएगा। So the battery current needed to supply half scale deflection is IH is equal to V divided by 2RH। Okay, so इतना करंट की सप्लाई की जरूरत पड़ेगी IH। तो to produce the full scale current, the battery current must be doubled, and therefore the total current in the circuit will be IT is equal to V divided by RH, and the shunt current through R2 is given by R2 is I2 is equal to IT minus IFSD। So this is the formula for the फुल स्केल डिफ्लेक्शन करंट। अगर आपको कैलकुलेट करने के लिए आ जाए कि भाई आप कैलकुलेट कीजिए तो दैट विल बी V डिवाइड बाय RH, and you have to calculate the RH, that is the parallel combination of the RM and R1 plus R2, and the shunt current through the R2 is given by I2 equal to I total current minus full scale deflection current। So that is a formula is given here। Similarly, the voltage across the shunt, अगर आप निकालना चाहें shunt के across voltage कितना है तो that is equal to the voltage across the meter, same। So that is the voltage across the shunt equal to voltage across the meter। So voltage across the shunt you can see from this figure, the voltage across the shunt R2 is basically I2 into R2, and voltage across the meter is basically IFSD into RM। So that gives you R2 equal to IFSD RM divided by I2। But you know that ki I2 is given as also is given as IT total current minus full scale deflection current। So we will place the value of I2 here, replace the value of I2 in equation, so R2 will become equal to IFSD RM divided by IT minus IFSD, right? Similarly, and we know that ki total current is basically equal to IT is equal to V divided by RH, ये भी हमें पता है। So now we'll replace the IT total current with V upon RH। So next equation, R2 equal to IFSD into RM divided by IT की जगह हमने V divided by RH minus IFSD, and further this can be reduced as कि RH को अगर हम ऊपर solve करें, so R2 will become equal to IFSD into RM into RH divided by V minus IFSD into RH। So to calculate the value of the resistance unknown value कि कहाँ पे इसको मुझे जीरो एडजस्ट करना है, so to calculate the value of R2 shunt resistance, the formula is full scale deflection current into meter resistance into half of the scale resistance divided by applied voltage, reference voltage minus full scale deflection current into RH। So that is the basic formula to calculate the value of R2। So that formula is very important to note। इसके ऊपर न्यूमेरिकल आ जाता है, right? This is the same slide। So since one more thing we have to see here, one more thing just to see कि RH is given as R1 plus R2 into RM divided by R2 plus RM। So that further अगर हम R1 की वैल्यू अगर कैलकुलेट करने की बात करें कि what is the how to calculate the R1, तो from the same relation we can calculate R1 also। So R1 will become equal to RH minus R2 into RM divided by R2 plus RM, or R1 is again is solved by putting the value of the here R2, R2 की वैल्यू इसमें सब्स्टिट्यूट कर दीजिए तो आपको जो फार्मूला जो है R1 वो निकल आएगा, एंड द फार्मूला ऑफ द R1 विल बी इक्वल टू R1 इक्वल टू RH माइनस IFSD RM into RH divided by V। So that is the formula of the R1, right? So R2 we determined from this formula, and R1 we determined from this formula. So both values of the R1 and R2 we can find out to make our ohm meter. अगर हमें ओम मीटर बनाना है, अगर हमें डिजाइन करना है ओम मीटर विद पीएमएमसी के साथ में, अगर हमारे पास में कोई गैल्वेनोमीटर है और उससे मैं अगर ओम मीटर बनाना चाहता हूं, तो आई कैन डिजाइन एन ओम मीटर फॉर माय own requirement. So value of the R1 and R2 we can calculate from here, and we can design that. So this is the same slide. So let us see the multi-range ohm meter. कि how can we design a multi-range ohm meters, means different ranges का अगर मुझे ohm meter डिजाइन करना है, क्योंकि ये तो एक सेम रेंज का है. अगर I have to determine 10 kilo ohm, 100 kilo ohm, 200, 1000, 1 mega ohm, and from 1 to 100 ohm, different ranges are there, because a single scale cannot measure the resistance perfectly. From of course it is from the 0 to infinity, but we cannot, if we want to measure a 100 kilo ohm and 100 ohm on the same scale, so it will be very difficult to differentiate between the two values on a smaller scale. So we have to differentiate the ranges. We have to uh, differentiate the ranges, or we have to make a different ranges of the ohm meter. So what we have done, we have just replaced the different value, different R1s here. R1, just you see, this is a meter. तो R2 की जो वैल्यू थी, जो हमारा शंट रेजिस्टेंसेस था, तो वी हैव जस्ट changed the resistance is value here. So we have inserted, you just see, that is the Rm is the meter resistance, that is the Rz, and this is the one more different value of the resistances are connected in shunt of the meter, that is R1, R2, and R3. So with the same way, with the same fashion, we can get the different ranges of the ohm meter. So let us now see the shunt type ohm meter. So now in the shunt type ohm meter, as you can see here again, that is the resistance, the R1 we are using, that is the variable resistance we are using, battery we are using, and the unknown resistance is connected in shunt, in parallel with the PMMC meter. Okay, and Rm is the meter resistance, Im is the current flowing through the PMMC, so through the meter, and there is a switch. So it consists of the battery in series with the adjustable resistance R1 and a D-Arsenval meter. इसके साथ connected है ये. Let us take the attendance now. Attendance ले लेते हैं पहले. So we were just so the unknown resistance is connected in parallel with the meter across the terminal A and B, hence the name shunt type ohm meter. So with this, this is the assignment for this for the second unit. He explain how the PMMC can be used as a basic voltmeter, explain the operation of an Arrington shunt, and define sensitivity of voltmeter. What is the significance of sensitivity in voltmeter? What is the loading effect? And explain the diagram, the working of TVM, and what are the drawback of TVM. So these are the 5 questions you have to write in assignment for this unit and submit me. Right. So this is the thing. This is the end for the today's class. So tomorrow we will switch to the next topic. तो ये हमारा पोर्शन रह गया था, ये मैंने पीपीटीज आपको शेयर कर दी है ग्रुप के ऊपर. तो आई थिंक यू कैन सी द गूगल क्लासरूम के ऊपर ये सारी स्लाइड्स शेयर्ड हैं, तो वहां से आप इनको रिवाइज